Good afternoon, everyone. Myself Albina Pathan, and my team members are Chaitali and Nikhil, and our topic is spectroflourimetry. It is guided by Dr. Vijaya Burge ma'am. So let's continue to our topic. The points we are going to study in this topic are introduction about spectroflourimetry, what is the theory of fluorescence, what are the factors affecting fluorescence, then what do you mean by quenchers, instrumentations and applications. So first of all, we will go through the introduction. So we have to know what do you mean by spectroflorimeter. So it is an instrument which takes advantage of fluorescent properties of some compounds. So we have to in this concept we study the fluorescent properties of compound, and this concept is used to determine the concentration and chemical environment of the sample. Using this concept, there is a new phenomenon known as fluorimetry. In this fluorimetry, the light is incident on a certain substance, and these substance emit visible light or radiations, and these radiations are known as fluorescence. These fluorescence is based on the concept called as luminescence. Now, what do you mean by luminescence is the emission of the light of the substance by a substance when an electron when the sample absorbs the radiations. The electrons go from ground state to the excited state, and on that excited state the electrons are unstable and they come back to the ground state. While coming to the ground state, they emit light as they lose the excess of energy known as photon. And depending upon this, there are three types of spectroscopy, that is fluorescence spectroscopy, phosphorescence spectroscopy and chemiluminescence spectroscopy. Moving to the theory of spectroflorimeter. So to understand the theory, we have to know about the singlet and triplet states. So these singlet and triplet states are this concept arises from the multiplicity considerations, that is multiplicity considerations that we consider in this concept. We consider the atomic spectroscopy and number of unpaired electrons in the absence of magnetic field. So number of unpaired electrons in the absence of magnetic field. So if there are n number of unpaired electrons, n is the number of unpaired electrons, it means that there is n plus 1 fold degeneracy, and depending upon this we can know the spin state of that electron. For example, if n is equal to 0, and according to this n plus 1 rule, 0 plus 1 means how much spin state is this? Only one spin state is present. So this is called as singlet state. Fine. Then similarly, if n is equal to 1, 2, 3, 4 and so on, so we can determine it is a doublet, triplet, quartet, quintet, etc. Then most of the molecules in the ground state are in unpaired electrons. So these unpaired electrons, when absorb UV light, they one or more of the paired electrons get excited to the singlet state. So during the excited singlet state, there is two possibilities. The spin of the electrons does not undergo any change, means the net spin state is 0. They will not change. And one of the second situation is that one of the more electrons will get unpaired, and two unpaired electrons which make a triplet state, means the one of the unpaired electron will get excited to the triplet state. So this is how it is there. In the ground state, the electrons are paired and they are singlet state in the ground state. In the excited singlet state, one of the paired electron get excited from ground state to excited singlet state. From the excited singlet state, there is possibility that at the metastable excited singlet state, it may go to the triplet state. So here we can see that from the excited singlet state, one of the following three phenomena may occur. At the excited state, the electron is unstable, and during the situation, the excited molecules may return from ground state to the ground state by collisional deactivation, means in the excited state they are at high energy. So because of this high energy, the electrons may get collide to each other, and due to collision they may lose some energy, and due to loss of energy the electrons may come from excited state to the ground state. So this is the one phenomena. Then second phenomenon is what? During its coming from excited singlet state to ground state, it will emit the UV light or visible photon. This is called as fluorescence. And the third situation is that from the excited singlet state, the electron may undergo to the metastable triplet state, and from metastable triplet state, when it returns to the ground state, it will emit a UV or visible photon. This is known as phosphorescence. And so to study this concept, we use a diagram. This diagram is called as Jablonski diagram. So what happened here is, we can see here the electron at the ground state. This is the ground state. From this ground state, the electron goes to the excited singlet state. So during the excited singlet state, three situations may occur. The electrons may come from the excited singlet state to the excited ground state by losing energy. This is called as fluorescence. And the third situation was that from the excited singlet state, the electron may go to the excited triplet state, and from the triplet state, the electron comes back to the ground state. During this coming back of the electron, there is occurrence of phosphorescence. And whenever the electron travels from excited singlet state to the excited triplet state, this system is called as intersystem crossing. Okay, so I hope you understood this diagram. Moving to the next slide. What are the factors affecting the fluorescence? So the nature of molecules, like whether it is an electron negative or electron positive group is attached to that molecule, it may affect the fluorescence property. The nature of the substituents, what type of substituents, what type of atom, neighboring atom is connected to that main molecule. This is also so the factors affecting the fluorescence are nature of molecules, nature of substituents, effect of concentration, quenchers, adsorption, radiation, oxygen, pH, and so on. So we can study two or three of the factors, like nature of the molecules. So all of the molecules cannot show fluorescence and phosphorescence. Only those molecules which can absorb UV visible radiation can show this phenomenon. In general, the greater the absorbance by a molecule, the more intense its luminescence is. And the next one is the nature of substituents. For example, an electron donating group or electron withdrawing group like COH or NO2 is attached to the compound. So it may alter the phosphorescence and fluorescence property of a compound. Then quenchers are the quenchers means what? There is a presence of some impurity or any other substances that may alter the phosphorescence and fluorescence property of the main compound. So similarly, the presence of oxygen and pH may also affect the fluorescence property. So moving to the instrumentations, there are two types of fluorimeters: filter fluorimeters and spectrofluorimeters. So in simple language, filter fluorimeter means there is presence of filter in that spectrofluorimeter. So we use filters to isolate the incident light and the fluorescence light. And in spectrofluorimeter, we use diffraction grating, like gratings and prisms. We use such instruments to isolate the incident light and fluorescent light. So this is the diagram of spectrofluorimeter. There is a source, there is an excitation monochromator. So what is the role of the excitation monochromator here is, it excites the light or radiations coming from the source, and this is passed from a sample that is in a single radiation to the sample, and whatever the light is emitted by the sample molecules, it is passed to the emission monochromator. The emission monochromator counts only that radiation which is emitted by the sample, and whatever the noise is there or the radiation from the atmosphere is there, it doesn't pass that radiations to the detector. So there is a photodetector measures the radiations, then amplifier, and then readout. So components of fluorimeters are: there is a source, filters or monochromators, there is a sample cell, and there is a detector. So the source we use in spectrofluorimeter is lasers, LED lamps, xenon arcs, mercury vapor. In xenon arcs and mercury vapor, these gases are are kept at high pressure, and when they are kept at high pressure, it generates a radiation. That radiation is passed through the sample. The most commonly we use is xenon arc lamp, since it produces light from UV to infrared, and xenon arc gives a continuous spectrum with nearly constant intensity, and the range is up to 300 to 800 nanometer. So filters or monochromators. So what are filters? Filters are the instruments which absorbs the unwanted light, and they transmit the required wavelength of light in the form of band, or in the form of a range. Then in expensive fluorometer we use primary filter and secondary filter. Primary filter absorb visible radiation and transmit UV radiation, whereas secondary filter absorb UV radiation and transmit visible radiations. This is the important component in spectrofluorimeter about primary filters and secondary filters. Then moving to the monochromators. Monochromators in simple language means converting polychromatic light to the monochromatic light. So there are two types of monochromator: excitation monochromator and emission monochromator, as we have studied in the earlier slides. So in excitation monochromator, the radiations in excitation monochromator we provide a suitable radiation for excitation of molecules, and in emission monochromator we isolate only the radiation emitted by the fluorescent molecules. And most common type of monochromator uses a diffraction grating. Then sample cell. The purpose of cell is to hold the liquid or liquid samples, and it is made up of quartz. It may be cylindrical shape or rectangular shape. And detectors we use are barrier photomultiplier tubes. In barrier cells we know that there are two layers. One, there is a ionic metallic plate, and on that metallic plate we apply selenium. Then above it there is a silver layer, and this create an potential difference between the electrons, and due to this we can pass the electrons. The electrons are detected, and the number of electrons will count the fluorescence. Then we also use photomultiplier tubes. Then what are the application of spectrofluorimeter? We can use spectrofluorimeter in organic analysis, then in determination of vitamin B1, vitamin B2, and also in fluorimetric reagent. We can also use in detection of alcohol, etc. Thank you.